All right. Hope everyone is enjoying the sunshine so far this morning. Just make sure in the chat, please say hi for attendance. We are going to start the next chapter. I do want to at least reiterate that if for some reason there is any last minute information from quarter 3 that I need to have, please get that to me ASAP. I have to have all the grades in the grade book, buttons punched, everything finalized before Mrs. Adkins finalizes everything in the main system, and that has to all be done by tomorrow. So please make sure that if I get anything after tomorrow, it cannot count ever again. So please be cautious of that. I'll put a reminder in Google Classroom. Hey everyone, thanks for being here. I tried to give a little bit of a heads up in case people forgot that we do start at 10:30 regularly on Monday and Wednesdays. So today we are going to start with the next chapter. It does have some overlap with concepts that we talked about with our similar triangles in the last chapter. Some books, this is chapter 8. Some books, this is chapter 9. I'm not quite sure for you guys where we're at. I can't remember now if it's 8 or 9, so forgive me if it kind of teeters back and forth. I'll always make sure that we say that it's a right triangle chapter. So the first thing that we're going to start off with is that overlap with our right triangle. So the first thing that I want you to do, and I really hope that you can do this with me today and not just watch. If you don't choose to do it with me right now, hey Sarah, Scarlett, Natalie, Landon, and Reagan, thanks for joining me. If you're not going to draw this right now with me, I really suggest physically doing this later as I do it. So the first thing that I'm going to draw is this very normal, I almost said regular, normal looking right triangle. And I'm going to label this, not very creative, ABC. And I'm hoping by now, because what we are going to find out this week should be pretty easy. We're going to review our Pythagorean theorem stuff that we have worked a ton on. I've already looked at some stuff that you're going to do, and to me seems pretty straightforward, pretty easy to be quite honest, because we've done so much with our right triangle information with the Pythagorean theorem. So right now what I want to look at is how we're going to identify the legs of our right triangle, and then obviously our hypotenuse is always opposite the right angle. So please keep those pieces and parts in mind. So here's our big right triangle. The next thing I'm going to do with this right triangle is, as I get my markers out and ready, I'm going to put an altitude. Now remember, an altitude starts at the vertex of a triangle and it goes to the opposite side and is perpendicular to the opposite side. And for many of you that obviously did our E&C pages, you saw that we had altitudes in one of the proofs, and we had to say that it was perpendicular. So in this case, we are going to make that point D down there. So we do have this altitude here. That went from the vertex of our triangle to the opposite side. We did call each of these guys legs, and we did identify this entire side as our hypotenuse. Again, we talked about it being opposite the right angle. So none of this is anything new. However, what we did create in here are another two triangles. Now I'm going to give a second. I'm going to be very quiet. It's going to kind of be uncomfortable over here. Hey, Matt, I want you to tell me what you know to be true about triangle ADB, triangle CBD, and triangle ABC. What is the relationship between those three triangles? Just type your answer in if you think you know. All right, they're all right triangles. So what else do we think we know about them? They are all right triangles. What is their relationship to each other besides that they're right triangles? Think a little bit about some of our other properties that might come into play. They are very good. They are similar. So let's talk about that we have three similar right triangles. Now, and you know what? Symmetry kind of does come into play here in that they are going to share a lot of characteristics. I'm not going to say that they're symmetric left and right where you could fold it across the middle and you would find that there's a line of symmetry because it looks kind of like that, like maybe if I folded this it might. You're not going to have that kind of line of symmetry, but we are going to share some characteristics. So if they are similar, and right now, there's no numbers on the page. So what's the only way right now we can determine without a doubt that these guys are in fact similar? You are correct. It is going to be by angle similarity. Now, here's the reason why it's angle. So let's now break this down. I want you to consider that we do have a right triangle sitting in here. And we have another right triangle sitting in here. But we do have our initial right triangle here. And in order for us to have angle similarity, we need two sets of congruent corresponding angles. So what's one pair of congruent corresponding angles? What are they going to have to be? Hey, as you're thinking, let's just go ahead and draw this first guy here. Here's A, B, D. Kind of rough, but it'll work. Here's another one. And here's our first one. Obviously not to scale. So if we have to have angle, we know that our right angles are all going to match. So our right angles are all going to match. We know that they are all similar because obviously these two guys are smaller than the green one. So we do have that they're similar. We have our right angles, but the one thing that we need to make sure is that we also look at this guy right here is reflexive. And this guy right here is reflexive. So in my triangle, what I know for sure is that angle A is going to be the same as this angle A because they're sitting on top of each other. And this angle C has to be the same as this angle C because they're sitting right on top of each other. And if I zoomed in really far, you'd be able to see pretty clearly that that blue and that green are sitting right on top of each other. That pink and that green are sitting right on top of each other. So what we have are those reflexive angles. So then what we have to think about is if these two guys are certain measures, and this measure matches here, so let's put it in perspective of a number. I'm going to name any random number. I typically ask you guys to do this in class, but if this guy is 23 degrees, okay, if this angle A is 23 degrees, somebody tell me what angle C here has to be. Good, 67 degrees, because we know they have to add up to 90. So again, this was just an arbitrary number. But I do know if this is 23 and it's reflexive, this angle A over here has to be 23. The only other measure this angle could be right here is that 67 degrees. So reflexive, already having those common 90-degree angles, the other angle still has to be the same complement. So remember, we had that theorem before. Angles complementary to the same angle are congruent. Happens here, and we just never noticed it. Well, the same thing here. If this guy was 67 degrees, the only other measure it could possibly be over here is 23. And I could have done any angle measure. But because these 90-degree angles are already going to exist there, these reflexive angles make that complement appear. The reflexive angles make that complement appear. So what we have is because of our reflexive, because of our 90, we immediately get angle-angle similarity. So angle-angle similarity right angles are congruent. Reflexive angles are congruent. Now, we do have to make these two smaller guys similar to each other. It's almost like the transitive property. If the pink one was similar to the green one because of reflexive and right, and the blue one was similar to the green one because of reflexive and right, these two are going to be similar to each other, again, by the transitive property. So I am going to suggest, just like we did in the last chapter, you should always look at where your acute angles are and where your right angles are. So, for instance, when we ask, where are these similar right triangles going to be? If I named this first one, and yes, we're supposed to put that right angle in the middle, but let's say I said triangle ABC is similar to the other two. How would I name those other two in order for this to be correct with correspondence? So think about that. How would I name those other ones so that they are correct when we talk about correspondence? All right, so let's take a look at this one. We have A, B, C. And then I have A, D, B. So let's take a look. 23, 90, 67. 23, 90, 67. So I am going to agree with the A, D, B. So we do have our pink one correct. 23, 90, 67. So acute, right, acute. Acute, right, acute. Acute, right, acute. 23, 90, 67. So again, I'm using this matching game to make sure that I'm going in the correct order. So the other one, though, says BDC, BDC. Let's check. Does that match the same order? Do we have 23, 90, 67? 23, 90, 67, 23, 90, 67, 23, 90, 67. We are correct. So again, B, D, C follows the same pattern. Acute, right, acute. 23, 90, 67. So one of the things that I'm trying to show here, because you're going to find that I did say our assignment is really, really easy when it comes down to this part. But we needed to look at when you match the correspondence, find your pattern. Either find it with your tick marks, where you look at, I could have said 1 right, or 2, because that's what we had for that 67, but find your pattern. And that's why I'm going to put down here 2390, 67, or acute, right, acute. Whatever your pattern is, find that pattern so you make sure those letters are in the correct position. Now, of course, I have looked at your no reassignment that I am going to give. So much easier than some of the other ones because, again, we're just going to be plugging stuff in like this. But it is very important that you recognize that they're going to move these letters around. So it may not be that they go A, B, C, where yes, the right angle should be in the middle. They may say BAC, just to then see, can you match the letters appropriately? So I get that they might not be in order the way they should, but it's to get you to pay attention to correspondence. So before we push forward with the rest of this, I want to make sure that we recognize that the minute we put an altitude in this original right triangle, it will create 3 similar right triangles. The way they are always similar is by angle, angle. Angle, angle similarity comes from our right angles being congruent, our reflexive angles being congruent, and a type of transitive situation to get the smaller ones. To be similar. So because all of them are similar to each other, they're going to be similar in pairs. And then remember, keep your correspondence. If you have to put in numbers, if you have to doodle to make sure they're correct, make sure you do so. Now, what we're going to do to finish today is we're going to redraw our right triangle and we're going to talk about what we see. So I'm going to give ourselves a new paper. I'm again going to suggest you draw this with me. And we're going to look at what are called geometric means. Oops, that's going to bother me. Yep, starting over. Okay, so we're going to define what a geometric mean is first so that we can truly understand what we're looking for. It is a repeated side of 2 similar triangles, like reflexive, so it's not reflexive. I want to make that abundantly clear. It's like reflexive, but they do not correspond. Meaning it's not going to match. So in one triangle, in one side it could be a shorter side, and I'll put the ER, a shorter side. In another could be a hypotenuse. They do not correspond. Okay? So these sides, or this one side, depending upon how you're looking at it, same length. So that's how it's alike. That's how it's like reflexive, in that it's the same length. They just do not correspond. So in one triangle, it's a shorter side, it's a leg. And in the other one, it's the hypotenuse. So a geometric mean, it's a repeated side of similar triangles. It's like reflexive, but they do not correspond. They are the same length because, again, they're going to be on top of each other. So we're going to start again with our triangle that we started with. And as I'm drawing this, if you can make a guess as to which segments you believe are repeated segments. They appear in two similar triangles at the same time, but they do not correspond, but they are the same length. Type what you believe those segments are in our chat as I go to label these. Anybody want to take a guess as to which segments are repeated segments in two different triangles? BD, you are correct. BD is a repeated segment. I'm going to go back real quick. That's why I use the same diagram. When you look at our last picture, BD is here and it's here. So it actually feels almost like reflexive because that's what's here. So you absolutely had BD correct. It's used in two different triangles. It's absolutely the same length. There's no way around it. It's not going to morph into something once I pull these apart. However, if you take a look in this right triangle here, this pink one, opposite the 23, it's the shortest leg. Over here, it's the longest leg because it's opposite the 67. They don't correspond. It's the shortest side in triangle, the pink triangle. It's the longest side in the blue triangle. And then I'm looking, oh, you took it away, you took it away. I'm trying to see what else we would have had. Anybody else? I couldn't tell. I know Sarah was right with BD, but I'm trying to see what else. I didn't even know you could retract a message. I like it. So we have BD was repeated. Anybody see any other repeated segments there? I don't want to give the answer away. I want to see if we're thinking. Look at all three of these guys. What do we see repeated? All right, let's take a look at, I agree with BD. We talked about BD. BC, you are correct, Landon. Down here, we can see that BC is this leg right here. So it's the leg here but it's the hypotenuse in the blue one. So you are absolutely correct. So it happens to be the shortest leg opposite the 23, or this random acute angle. You're absolutely correct here. It's the shortest leg, but it's also the hypotenuse over here. They definitely don't correspond. This is the longest side. This is its shortest side. So these two correspond in that they don't correspond, but it's the same segment. So the same repeated length gets used exactly the same way, but in two different places. They just do not correspond. So what's the other one? So we've said BD because it corresponds here, or it's the same length. They do not correspond. Shortest side, longest side. Shortest leg, longest leg. Same length, same segment, don't correspond. Hypotenuse here, shortest leg here. Same length, same segment, they don't correspond. And you are correct, Mr. Hirschberger. AB. AB is a leg in this green one, but it's the hypotenuse in this triangle. Same length, same segment, they do not correspond. So when you're looking at all of these, what you're going to find is that the ones that we will call our geometric mean are those repeated pieces. It is always the original leg, and the altitude. It is always the original leg, and the altitude. So now what I'm going to ask is that you make one more observation before I put you out of your misery. If we have just determined that it's the same segment, the same length, but they do not correspond, and it's always these three, what one thing in common do all three of those segments have? What one thing in common do all three of those segments have? And if I can get somebody to take a good guess over there in the chat, I will stop after this, and I won't ask you to make any more observations, but I'm hoping this will help in the long run. I really want us to use our thinking caps. What one thing in common do each of these segments have? Think of the words I'm using. Well, A is part of AC, but I want you to think, this segment is AB, this segment is DB, and this segment is CB. What do each one of these segments? Those three we have determined are our geometric means. They all share point B. You are spot on, Natalie. Very good. They all start at that right angle. So if we want to always say what our geometric means are, they all come out of that original right angle that we first drew. They all come out of that original right angle that we first drew. Now, when we do this, we know that eventually I mentioned the Pythagorean theorem, and we're going to have a lot of other formulas. So what we call some of these are our altitude on hypotenuse formulas. They are derived from proportions that we could do. I'm going to look again right here. We could write our proportionality statements for these two triangles. We could write our proportionality statements for these two triangles. We could then match the proportionality statements, again, that transitive feel for those two, and we're going to have proportions, just like we did in the last chapter where we can cross multiply and solve. So there's a couple ways that I'm going to have us kind of memorize how to do this. I'm going to first show you how you could look at this as, here's our hypotenuse, and here's part of the hypotenuse up to D. Here's the other part up to D. And you can see that we have our one triangle up here, so leg 1, part 1. You have another one, part 2, or leg 2 in the other triangle. So when we're looking at, if we were to write our proportions, we could have that our altitude, if we want to do this, and I'm going to give you some options, whatever you feel is best when memorizing these. Our altitude is the geometric mean between the two parts of the hypotenuse. So again, if we had our proportions and we are to cross multiply, our altitude would match with these two. So think about that last paper where if we talk about our part 1, here is a leg in this triangle. It actually corresponds with this leg in our other triangle, but it's called the altitude. And then our altitude actually corresponds with that other part. So when we look at this proportionality statement, notice how our longer leg corresponds with the longer leg. Our shorter leg corresponds with the shorter leg. It's a lot to remember, so one of the tricks is you can do this. Notice where our altitude is placed in our proportion. It's in the means position, and our parts are in the extremes position. Now, we also talked about our legs. If we were to write out all of our proportions for our similar, are our geometric means as well. So our leg, depending upon which one, so the legs, is the geometric mean between, B/N is between the hypotenuse, so the whole thing, and the adjacent part. So whatever leg we're talking about, again, goes in the means position, and it is always between the hypotenuse and the adjacent part. Well, if I'm talking about leg 1, shouldn't its adjacent part, if the leg is AB, the adjacent part should be AD, because it's adjacent, it has to share that point. So that's also why sometimes looking at it this way, you can see leg 1, part 1 all goes right here. Which does mean, because it's the same thing, just on the other side, our hypotenuse, leg 2, part 2. It's the exact same formula, just on the other side. Now, some people like it taught this way. They'd rather see the proportions. They'd rather see what the geometric mean is, the altitude, and what its parts are, what the geometric mean is, and what its parts are, what the geometric mean is, and what its pieces and parts are. Some people like looking at it that way. Now, obviously, what's the whole purpose of this? We are eventually going to solve for missing lengths. Not to mention, it's a nice bit of a shortcut, so you don't have to go through all the steps of, okay, they're similar, and now that they're similar, I can set up my proportionality statement, and now that I have my proportionality statement, I can use my means extremes product theorem, so cross multiply, and go through everything. So these three you can use to solve for lengths. Okay. That is one way we can do this. Another way that we can do this is in your textbook specifically. Not in any of the other textbooks have I ever seen this. So I am going to put that asterisk that in your textbook specifically, and I will scan as much as I can. And load that for you. Some of you may find this way easier. We'll start with our triangle in the same direction so that at least that's consistent for now. All right. The difference is, instead of talking about segment AB and segment BC and segment BD and segment AD and CD and AC, we are going to label opposite A lowercase a, opposite here, we're going to keep consistent with the Pythagorean theorem. So here we're going to go ahead and just name it B. So A and B for Pythagorean theorem. You're going to see our Pythagorean theorem type idea, A squared, B squared, C squared. That makes sense. We are going to call our altitude H. In your textbook, you'll see that it's called H when I can get that scanned in for you. And just because there's no other variables, I am certain that they have X and Y placed in there just because they're different variables. The trick is, when I would be in the classroom, and I'll show you this here in a moment, I could use any letter. Doesn't matter. Of all my red letters, can you tell me in the chat which ones are the geometric means again? It's a little faster doing it this way. Yep, that's pretty pretty straightforward. A, B, and H, again, they all come out of the original right angle of our biggest right triangle. So instead of starting with the proportions, so again, here's these proportions. If I was to cross multiply, what's going to happen when we multiply something by itself? When something is multiplied by itself, what do we end up saying? Yep, it is absolutely squared. So in each one of these, you can see if I cross multiplied altitude times altitude, it's going to get squared. Leg times leg, it's going to get squared. Leg times leg, it's going to get squared. So let's say we cut to the chase and we've already done our cross multiplication. We are going to have b squared, a squared, and h squared, because our leg is multiplied by itself. The altitude was multiplied by itself. The leg was multiplied by itself. So this is where we've already done that cross multiplication. So now what you need to look at is if we multiplied here, the two parts would get multiplied together. If I multiplied here, the adjacent part and the hypotenuse, the adjacent part and the hypotenuse. So B, what's its adjacent part and what's the hypotenuse? All right, so if we have B, the adjacent part to B, I will agree, is the hypotenuse is C, but what's the adjacent part? So remember we talked about part 1, part 2. What's the adjacent part? We already named altitude. So if B had that adjacent part, what's going to be its part? Yep, we're going to do y times c, which then means if it's exactly repeated on the other side, a squared would have its adjacent part x times c, and then our h squared was supposed to be part 1 and part 2, x times y. Notice how over here on the right side of all of our equations, you don't see A, B, or H because you don't want the geometric means labeled. You've already multiplied those together. So on the left side are always my geometric means. We've identified them because they all came out of that same that same point B. And we square each of those, which means this technically was used twice, this was used twice, and this was used twice. Notice how now if I've written it, those are used twice, these are used twice, that's used twice. So every one of these variables has now been used twice. So if I can write out all of them, I can check to see if they're all written twice. So that's another way to look at this. So I'm going to turn my triangle here just to show you, and I'm going to change some of the letters just so that you can see what I'm looking at. And I'm going to go ahead and name this F, G, P, T, M, and C. Okay. I didn't name the segments this time. I just named the lowercase so that it's a little easier just to identify at the beginning here. Anybody want to tell me what the geometric means are in this one? Which ones stand for the geometric means? Remember some of the patterns we looked at? Yep. Again, they're all going to be right out of that original right angle. So it is going to be F, G, and C. And a lot of times we use these variables over and over and over again. So we're going to take F, G, and C, and we know that they all get squared. I do not want to use those letters again because I've already had them incorporated into that proportion. Again, we've already done the proportion part. We're cutting to the chase now. So F squared, its adjacent part would be P. The whole hypotenuse would be M. G has the two parts. That's P and T. And C's adjacent part is T, and the whole hypotenuse is M. So it is a different way to look at this, and I could draw 100 of these and change the variables. But what ends up happening is it all comes back to this idea of all of those proportions from our similar triangles. If we were to match up where we see the altitudes being repeated or the legs being repeated, all of these formulas that I have right here come from these proportions. We've just already done the cross multiplication. So, finally, last thing we're going to look at today is so that we can see where this is going. Okay, here are two examples. I'm going to give you a second to copy both of them down. All right, so let's go ahead and look at the first one. So I want to first identify which is my geometric mean. So first off, it's going to be a dead giveaway that you're using even this concept, because it's going to be the only time that you actually see this right angle showing up in the middle of another right triangle. So we see a right triangle and we see this segment that creates this right angle. So you see two right angles. This is the only time you're going to use this concept, is when you have this altitude. If it is not an altitude, it doesn't work. So first thing I'm going to do is I recognize that I have my geometric mean. And I either want to use these formulas, depending upon what I'm most comfortable with, or I want to use the proportion. Again, I don't care. However, it's easiest for you to memorize. All right, so you either decide to use your proportion or the formula. Either way, what we have to remember is that we're dealing with the leg. So if we use our proportion, we can call it leg 1, but it's supposed to be with our hypotenuse and its adjacent part. If we use our formula, we know that it's supposed to, again, be the leg squared equals the adjacent part times the hypotenuse. Difference is I don't have the entire hypotenuse labeled. So if I want, I can label the entire hypotenuse something. So then I can get that x squared equals 4 times c. Well, isn't c already 12? You can just add that. You know that that's the case. So x squared would equal 4 times 12. And we end up with x squared equals 48. And just like before, when we take our square root, you want to make sure that you look here, and you can even use your context clues. That's why sometimes I like this whole just jump to the cross multiplication part, because you see a 4's here and a 4's here, which means 48 is divisible by 16. And when I do take the square root of both sides, I remember that this is actually 16 times 3. So when, again, we answer this, we want this to be 4 radical 3. It wants exact values all the time. So figure out which is your geometric means, and then either use your proportion or our cross-multiplied formulas that you've already seen. So last example, we're done for the day. Was a doozy of a lesson today. We're going to go over it again on Wednesday. Here's the thing. In this one, my geometric mean is here in the middle. It's my altitude. So I identified my geometric mean. I'm going to use either the proportion or the cross multiplication formula, but that told me before that when I filled in my proportion, the altitude went in the means position and the parts went across from each other. Well, I only have one of the parts. So that means I've got to figure out what this guy is here. I also, though, have a geometric mean there at 10. So unfortunately, I got to do part of the problem in order to answer the actual question that's being asked, which means I've got to figure out what this guy is again. So I need to account for the entire hypotenuse, because here's a leg, and we know over here, we just saw, leg needs hypotenuse and its adjacent part. So I will need to do the hypotenuse, leg, leg, and its adjacent part. Or 10 squared equals 6 times c. Leg squared equals part times hypotenuse. So 100 equals 6 times c, and c is going to be 100 ABC 6. And we end up with a beautiful, sarcasm, 16 2/3. All right, so if that's the whole thing is 16 2/3, this guy has to be 10 2/3. Because the whole thing was 16 2/3. So now, if I wanted to plug this in, I could have our 6x, x, and 10 2/3, or altitude squared equals part times part. And I'm going to take the easy way out. I already have the 16 2/3 in my calculator. I'm going to just subtract that 6, so I have my 10 2/3. So 10 2/3 times 6 gives me a very nice 64. That's interesting. 10 ABC2, ABC3 times 6 is a beautiful 64. So x squared equals 64. Kind of shocked myself with that one, because I made that problem up and I did not anticipate it coming out to be that beautiful. I honestly thought that it would have been something else with a radical. I am going to tell you that for me, I will always cut to the chase, and I have a tendency to now only rely on these. The only time I use the proportions is when it's specifically asking which is the geometric mean, and I kind of use that as a go-between. Okay, very lengthy lesson today. I only want you to practice tonight identifying. You are going to see that the no reassignments will be loaded, but I'm giving them to you now, not as they have to all be done by tomorrow, but you'll have 2 assignments. You will have through Sunday to get them done. The first one is just how we started today. You'll see it's going to identify triangles. It's going to ask for the geometric means. That's it. The second one is just the Pythagorean theorem. So, with that being said, I am done. You are not going to have any written work this week. But I do want you in the no reassignments. So, we will go over more on Wednesday. There will not be any new information on Wednesday. So I will see you all then. Thank you so much for playing along and for answering questions. I really, really do appreciate it. Have a great day, guys. Miss you all.